This is lesson 10.5, which is inverse matrices and systems of equations. The essential question is, how can matrix inverses be used to simplify the process of solving a system of linear equations? Okay, so how can we solve the matrix equation? So if we think about something way simpler first, if I have something like 3x equals 6, most people would say, okay, you're going to divide both sides by 3 and you get x equals 2. Now, if we think about it a little bit more complicated for a second, if we have 3x equals 6, what we're doing when we divide by 3 is we're multiplying by its inverse. So I could multiply each side by 1/3 and I end up getting the same answer. So that's what we're going to think about when we're multiplying and we're solving these matrix equations. So how could I solve the matrix? So if I have matrix A, I'm going to call this matrix A and this matrix B. So if I have matrix A times my variables, x, y, equals B, if I want to find out what these variables are equal to, I want to cancel out matrix A. And what we've learned in our previous lessons, the way that we cancel something out is we multiply by its inverse. So if I take the inverse of matrix A times A, that's going to cancel out to my identity matrix times our x, y. And then over here, if I take the inverse of matrix A times B, that is going to give us our solution. Okay, so let's look at what that's going to look like. So the first thing I need to find is I need to find the inverse of matrix A. So if I find the inverse of matrix A, again, if you want to watch the previous lesson, that talks about how to find the inverse. The inverse of matrix A is going to be 1/2, 1/4, 0, and 1/2. Okay, so if I know that if I multiply this side by the inverse of A, I'm just going to get the identity matrix. So really, to find x, I'm going to call this matrix x. To find x, I'm going to take the inverse of A times B. Now it's important that it seems weird that we're not multiplying on the opposite side because with numbers, we know that multiplying 2 times 3 is the same as 3 times 2. But I have to watch my dimensions, and I know that this is a 2 by 2 and matrix B is a 2 by 1. So if I try to multiply B times the inverse of A, those dimensions don't match up and don't work. So that's why the inverse needs to come first, because it's a 2 by 2, and that multiplied by a 2 by 1 will give us our 2 by 1 that we're looking for. So we're going to take 1/2, 1/4, 0, 1/2, and we are going to multiply that by 2, 8. And so when we do that, we get 3, oops, no fraction, just a 3, okay, 3, 4. So that means that our xy is equal to 3, 4. So we'll look in the next example, but basically we're solving a system of equations using matrices. Okay, so this next example is just asking us, how can we set up this system of equations like we've solved before by hand, algebraically? How can we set it up as a matrix so that we can use matrices to solve? So to set up this matrix, we are going to take the coefficients, so 3, -5, 2, 1. We're multiplying it by our x and our y, and that is going to be equal to the 7 and the 4. So this is similar to what we just looked at right here on our previous example. So now that we know the setup, now we can go back and find xy by taking the inverse of matrix A times matrix B. Now this is super helpful. We know how long it takes to solve systems of 3 equations with 3 variables. So we can use technology and we can solve something like this using a matrix. So again, we would take our coefficients, 1, -2, 4, 2, -8. I'm missing something there. Good thing I caught that. Okay, so if I'm missing a variable, I need to put a 0. So on that second line, I don't have a y. So I'm going to put a 0 for the y, and I'm going to put the -8 with the z. Then on my last line, I have 3, 1, -2. So you got to be careful to look out for those missing variables. Okay, this time I'm going to have x, y, z, and then equals 9, -24, -1. So that's how I would set those up. Okay, so this last example, this is with the use of technology. So we're not finding the inverses of 3 by 3 matrices by hand. You can, but we're not. But you can find them on using technology. So Desmos matrix is an excellent tool to find the inverse of any matrices. So the first step, you can see what they did is they took our system of 3 equations and they turned it into a matrix. So if we look right here, we have -3, we're missing a y, so we put a 0 there, and then the 1 for the z, -1, 0, 2, 2, -1, 0. So then we're going to set this up in whatever technology we're using. So either a graphing calculator, Desmos matrix, but we're finding the inverse, if I like to call this matrix A and matrix B. So we're going to find the inverse of matrix A. So that's what was found right down here using technology. And then we're multiplying. So this is the inverse of matrix A times A. And we know that that's going to cancel out and give us the identity matrix. And then here we have the inverse of matrix A times B. And that's going to give us our solution. So the one thing that this did not write is if we're finding the solution to a system, we know that we're going to write it as an ordered pair. So this would actually be an ordered triple. So this would be 4, -2, 3. So we can use matrices to save us all the work of having to do that algebraically. Again, just want to point out that the reason that we're multiplying the inverse before the matrix B is because this is a 3 by 3 and this is a 3 by 1. And so we have to have those matching middle numbers in order to multiply the matrices. If we tried to do it the opposite way, those middle numbers wouldn't match and we wouldn't be able to multiply.